As a part of Unlock Design Contest, we have designed a project called Speed Control of Train based on signals. The main goal of our project is to avoid train accidents caused due to negligence of the driver or when he is unable to view the signals due to fog coverage. In this modern world of internet and newspapers, the front pages are mostly covered with the news of accidents and death of innocent lives. There will be heavy loss of wealth and humans in train accidents compared to others. In India, we frequently hear about train accidents caused due to some negligence. These accidents are considerably reduced if we provide better solution for this. We can avoid only if the driver controls the train speed properly based on signals received by him. With this inspiration, we started our project called Speed Control of Train based on signals, which automatically controls the driver's speed. Accidents do not cause but are made. So our project will ensure that safety of lives and provide people a safe journey. Here we are having transmitter part and the receiver part. In the transmitter part, the main blocks involved are signal system, microcontroller, which is MSP 430. It is a 20-pin microcontroller. Next coming the IR modulator and the driver circuit and the transmitter. Here is the reset logic. Coming to the signal system, in the signal system there are 3 LEDs which are connected via 1K resistors. The output of the signal system may be either red, yellow or green signal. Depending upon the requirement of our system, we send the signal to the microcontroller MSP 430 F2111. If we need to stop the train, we send red signal to the microcontroller via the signal system. Next block involved is the reset logic. In the reset logic, we provide rest signals to the microcontroller. This is constructed with 8.2 kilo resistor and 10 microfarad capacitors. Reset is 89C252 uses heavy active high reset pin. It means it gives high to machine cycles. The simple RC circuit is used to control the VCC supply and the reset pin until the capacitor gets charged. The microcontroller is reset state. Next block is the crystal oscillator. Crystal oscillator here we are using is CDCE 421. This block provides necessary frequency sine wave to the microcontroller. The frequency is converted to the square wave within the microcontroller. Xin is the input of the inverted oscillator amplifier and the input of the internal clock operating circuit. Xout is the output of the inverting oscillator amplifier. The next block involved is the IR modulator. IR modulator is an unstable multivibrator which generates 35 kHz frequency while receiving bit 0 in the transmitter pin of the microcontroller, and the transmitter pin is decided by the 4.7 kHz frequency while receiving bit 1 at pin 4 of the reset pin of the 555 timer. The data from the transmitter pin of the microcontroller is inverted with the help of a transistor. IR driver is a current cum voltage amplifier, which means a power amplifier. Then it increases the input power received by the output of the IR modulator. IR LED here is a trans receiver and this acts as a transmitter. Here we are using CC2500 trans receiver. This is a low cost, low power 2.4 GHz RF trans receiver. Now coming to the receiver section. The main block of the receiver section is the microcontroller MSP430F2234. It is a 40-pin microcontroller. And the next block involved is IR receiver. This is also a trans receiver CC2500. And the reset logic and the crystal oscillator are same as in the transmitter part. The next block involved is dot matrix LCD display. The display is connected to the output port of the microcontroller, which displays the signal information on 2 rows. Now coming to the buzzer driver and the buzzer, it is connected to the output port of the microcontroller. The buzzer is connected to the buzzer driver's transistor. Here we are connecting buzzer because if red signal or yellow signal is detected, the train speed must be controller. We provide buzzer because it gives a detailed information without neglecting the driver by giving a buzzer. Now coming to the speed control of the regulator switch. The speed of the regulator is constructed with 2 relays operated with 2 transistors which are connected to the output port of the microcontroller. By using these relays, the motor of the train can be controlled. Thus, the speed of the train can be controlled by using the signals detected in the transmitter part. In the transmitter section, LEDs are connected to port 1 red color and port 1.1 yellow color and port 1.2 green color via 1K resistors from 5 volts. These are the 3 LEDs which we are using, and here when yellow signal is given, yellow LED will glow, and when green signal is given, green LED will glow, when red signal is given, red LED will glow. This is the microcontroller which we are involving here, and this is the IR modulator circuit, crystal oscillator, regulator, and the transmitter part is given in this. And this is our trans receiver which acts as transmitter part in this section, and this is the IR LED. This is the receiver part involved. The microcontroller receives IR data from the RxD pin, and the receiver data is accumulated in the serial buffer of the microcontroller. If the data compares with the predefined code 000102, if the code received by the IR receiver equals to 00, then the motor will be stopped. If the code received equals to 01, we apply low voltage to the motor, and thus the speed of the train is controlled and it's travel with low speed. If the code equals 02, then the motor rotates with full speed and apply for 3 volts. This is the transmitter part, and now we can apply a signal. When we apply yellow signal, first no signal is detected is displayed on the screen. When no signal is detected, the LCD displays no signal detected. And now when we apply a signal yellow in the transmitter part, yellow signal is detected and the train gets slowed. The speed of the train is slowed. When green signal is detected, the LCD displays green signal and normal speed. Thus the speed of the train goes with normal speed. Now when we give red signal in the transmitter part, now the red signal is detected and the train is stopped. Now we send yellow signal, next green signal, next red signal. Here we are provided with a buzzer, and this activates the driver. This project is aimed to conserve energy and power in various sectors such as railways, home appliances, etc. And it is successfully completed and implemented. By using this system at Vijayawada railway station, we can save around 5 lakh per annum. Here in this particular design, we are using microcontroller AT892051 and microcontroller AT89C52, and these are non-TI products, and we are trying to implement this by using MSP430 microcontrollers. We faced some problems in that. We are trying to implement with these microcontrollers with MSP430s, which are the TI products, but due to some reasons we couldn't do it, and we implemented this with these 2 microcontrollers.